Dr.P.Aruna Devi, Assistant Professor, Department of Computer Technology, Dr. S.N.S. Rajalakshmi, College of Arts and Science. Today we are going to see about wireless frequencies. That is, there are different wireless media and which consist of different frequencies. Today's session is about frequencies. First, wireless transmission frequencies. There are different frequencies are accessible to the wireless media. Let me see. Microwave is a highly directional one, then point to point, and it will accept 2 gigahertz to 40 gigahertz of the frequencies for transmitting the information. Next one is satellites required omnidirectional. Then it is an frequency will accept 30 megahertz to 1 gigahertz, whereas an infrared will accept broadcasting technology 3 into 10 to the power of 11 to 2 into 10 to the power of 14. Infrared, that is in frequency ranges, it is only used for the infrared optionals. That is it will transmit information through the infrared as a local one. Wireless transmission frequencies. So electrical conductor used to radiate electromagnetic energy or collect electromagnetic energy transmission. That is the wireless transmission required electrical conductor for transmitting the information either through the electromagnetic waves or radio waves or infrared waves. So here the radio frequency energy from transmitter, that is radio frequencies can be transmitted, converted to the electromagnetic energy. It can be done by using the antennas. So radiated into surrounding environment receptions. Electromagnetic energy impinging on antenna, it also converted the radio frequency electrical energy to receiver for receiving the information from the both sender and the receiver. That is, the wireless media required some electrical conductor for transmitting the information and for conversion. Radiation pattern, that is, power radiated in all direction. That is, radiation can be extracted in all different direction, but it is not performance. That is, the performance is not same in all direction. Due to some weather condition, there may be a vary. Sometimes the signal may be proper in single direction. In other direction, we cannot extract same signals due to some weather condition or fog or a wind, etc. Isotropic antennas is used in this space. It radiates the information in the spherical pattern. Spherical means automatically from sender to receiver in same direction. Spherical pattern, it will receive the information. I will show the diagram, then only we can easily understand the process of radiation. Next, parabolic reflective antenna. So parabolic, it like a parabolic shape. So it receives the information as a terrestrial and satellite microwave view. So it is it shows some line and point for transmitting the information, but the point should be in the fixed way and line should be in the direction, different director way, directs way. That is a direction, it can be different, it can be transmit the information in a different direction. Result parabola about axis to get paraboloid. Then cross section parallel to axis gives parabola. Cross section perpendicular to axis gives a circle line. Source placed at the focus will produce waves reflected from parabola in parallel to axis way. Creates theoretical parallel wave of light, sound or radio waves that concentrated at different focus, whether detector is placed in between them. Let us see the diagram of the parabola and cross section of parabolic antenna showing the reflective portion of the given information. So there are different directrix A, B, C, D. See the diagram, there is a parabolic way, there is an x and y axis. If you are focusing the data from one to another one, antenna will reflect the information through A, B, C, D is a directric way. It will transmit the information through the y axis. So the parabolic way, it will reflect the information. See in right side, cross section of the parabolic antenna showing reflective property. So if the data is reflected means automatically reflection can be pointed to other direction. Next, antenna gain. Measurement of directionality of antenna. the power output in particular direction compared with the produced by isotrophic antenna. Isotrophic means it's above layer above the earth. It's called as an isotrophic layer. So it can be easily identified by the antennas for transmitting the information. So it can be measured by decibels. So result is loss in power in another direction due to some shapes and sizes. There are different terrestrial microwave, parabolic dish, focused them, line of sight. So long haul telecommunication, higher frequency give higher data rates. Terrestrial wave, I will show the example. Satellite microwave, already we know that satellite communication, data can be communicated from one satellite to another one through some media. So it will covers geostationary orbit. Then it is used for television, then longer distance telephone, private business network calls are used for satellite communication. Let us see the diagram. It is a point-to-point communication. In one earth station communicate with another through the satellite antenna. This is only through the satellite, single satellite. If we call it as a satellite broadcast link means more than one different receiver and sender side are there. Multiple receivers can be extract information from the single antenna, satellite antenna. The next broadcast radio, it is an omnidirectional. For example, broadcast radio is FM radio, UHF, VHF, television online. It is used for multipath processing. Infrared, it is example for infrared rays, TV remote control. Easily we can transmit the information infrared only through this short distance. It is not used for long distance because it can be blocked by walls and other obstacles. Wireless propagation line. Today I have said ground wave, sky wave, line of sights. So ground wave propagation from ground to ground. Sky wave means it will data can be sent to some satellite. Line of sight means it should that is data can send through the line of sight. There is a line for transmitting the information. Let's see the example. Ground wave, transmit antenna, receiver antenna, signal can be propagated. This one is sky wave. Already I said that there is an ionosphere above the earth. So data can be transmitted. It can be reflected over the ionosphere. It will receive at the receiver end. Like this only they will propagate the information. Then line of sight. I said that there is a line between the two satellite communications. Through the same line of sight only they will receive the information. Line of sights. So signal disappears within a distance greater for lower frequencies. Then water vapor and oxygen absorb the radio signals. They can face with a lot of issues while transmitting the information. Multipath. So line of sight requires some multipath. Better to get line of sights if possible. So there may be a directed signal. Does not contain any signal for transmitting. Through that same line only it will receive the information. There may be a refraction while transmitting the information. That time there may be a packet loss. This is the example for multipath interference. Same antenna, that is one antenna to communicate with another one. Then mobile radio, it can be communicate with different directions. That in each and every antenna can communicate with either home, car, other apartment, institutions, etc. Like that they can communicate. That is called as a mobile radio station. So from this we studied about different microwaves and its usage. Thank you.